Hi, in this video I'll cover the explicit formula of the geometric sequence. In the previous video I have explained the recursive formula of the geometric sequence, and now let us see what is the explicit formula. So let us consider the sequence 2, 6, 18, 54 and so on. Okay, let us first determine whether the given sequence is a geometric sequence or not. We know that a sequence is a geometric sequence if the ratio of the consecutive terms is always same. Correct? So an over an minus 1. All these ratios of the consecutive terms, if they are same, which is called the common ratio R, then such sequences are called the geometric sequence. In our case, a2 over a1 is 6 over 2, which is 3. a3 over a2 is 18 over 6, which is again 3. a4 over a3 is 54 over 18, which is again 3. There is a common ratio among the consecutive terms, and therefore this sequence is a geometric sequence. Now, what do we see here? That the first term a1, it is the first term. So the first term of the above sequence is 2. So a1 is 2 and the common ratio r is 3. The second term a2, which is 6, can be written as 2 times 3. The 6 is obtained by multiplying the common ratio to the previous term. Okay, then a3, the third term in the sequence, is 18 and 18 is obtained by multiplying a 3 to 6. So I can write a3 as 6 times 3. And what is 6? 6 is 2 times 3. So I can write 2 times 3, which is 2 times 3 square. Similarly, 54 is obtained by multiplying a 3 to 18. So the fourth term, 54, can be written as a3 times 3. a3 is 18, which is 2 times 3 square. So 2 times 3 square times 3, which gives you 2 times 3 cube. Okay, now let us see what has happened in each of the case. We see that the power of r is always 1 less than the position. Here the position of the term was 2 and 1 less than that was the power of 3, which is the common ratio. Here the position was 3 and the power was less than 1. So 3 minus 1 was 2, and here the position was 4 and the power was 1 less than the position, it is 3. So similarly, the nth term of the above sequence can be written as 2 times 3 to the power 1 less than the position, which is n minus 1. And 2 is nothing but a1 and 3 is nothing but r. So a1 into r to the power n minus 1 gives you the nth term of the series. This is the explicit formula. So if we have a series, a1, the second term of the series, will be given by a1r. The third term of the series will be given by a1 r square 1 less than the position. a4 can be given as a1 r cube and so on. an, the nth term, can be given as a1 r to the power of n minus 1, and using this formula we can find out the nth term of a geometric sequence. And this formula is called the explicit formula to find the nth term of the geometric sequence. Okay, let us do one example. Find the 15th term of the sequence 1, 2, 4, 8 and so on. So our first term a1 is 1. The common ratio r is given by 2 over 1, which is 2. It is a geometric sequence. The next term or the consecutive terms are obtained by multiplying 2 to the previous term. So that becomes a common ratio. So according to the formula, an is equal to a1 r to the power n minus 1. a15 should be equal to a1, which is 1, times r, which is 2 to the power of 15 minus 1. Okay, so this gives you 2 to the power of 14. So the 15th term of the above sequence is 2 to the power of 14. I hope this example is clear to everyone. Let us do one more example. Which term of the sequence 1, 2, 4, 8 and so on is 128? Okay, so it is again a geometric sequence as in the previous example. So the first term is 1. Common ratio is second term over the first term, which is 2. Now we don't know the position of the term, but we know that the nth term is 128 and we have to find out n. Let us apply the formula. So an is equal to a1 times r to the power of n minus 1. And let us put in the values. So an is 128, a1 is 1, r is 2 to the power of n minus 1. This gives you 128 is equal to 2 to the power of n minus 1. If we prime factorize 128, we see that 2 to the power 7 gives you a 128. So that's equal to 2 to the power of n minus 1. We know the rule of exponent, that in an exponential equation, if on both the sides of the equality you have numbers with the same base, then you can equate the power. So 7 is equal to n minus 1, which gives n is equal to 8. So this means that 128 is the 8th term of the sequence. I hope this example is clear to everyone. If you have any doubts regarding this video, you can send me an email at kirti.mathacademy@gmail.com. This is my YouTube channel Mathacademy. If you have liked my videos, please don't forget to like, share and subscribe. Thank you.